Hello everyone. Today, during my talk, I will be not only telling you about my topic, but I'll be asking you some questions along the way. So if you take up your phones and log into this thing using either a QR code or the link at the top, then you can follow along and hopefully we'll have some extra engagement. My journey at Mentimeter, which is where I work and we make these kind of presentations, has been a lot about trying to make it possible for developers to deploy as often as they want and as quickly as they want, so that we allow them to iterate super quickly, so the deployment doesn't become a bottleneck. And as a part of that story, I'd like to show you two graphs. On the left side, it's all deploy time graphs in the last 8 months at Mentimeter. The one that we have on the left is the actual data, so every single data point, and the one that we have on the right is the rolling average of that very same data. So what stands out to me about these graphs is that on the left-hand side, when we've got the spiky data, between November and January last year, it's definitely had quite a big difference on our overall average deployment time that we were able to achieve at the company. But somehow, magically, after January there, we managed to drop our average deploy time by quite a lot, but also to make the experience better and less spiky. And today is all about how we made that happen and the technology behind it. And really what we wanted to do was to make end-to-end tests particularly less of a bottleneck for our deployment pipeline, our deployment machinery, and at the end of the day, let our developers iterate. But before we get there, a little bit about me. My name's Oliver Stenbom. I'm a DevOps engineer at Mentimeter. I've been there the last 2.5 years. Before then, I did a master's in engineering, particularly on serverless computing at Imperial College. I love the C, I love lots of side projects, and I'm really dedicated to this developer experience. So, enough about me. What about you? Tell me a little bit. In your organization today, are you using end-to-end tests at all? Extensively? Maybe just a little bit? Or maybe not at all? So that we get a feeling of what the audience here is like today. And I'm going to sort of use the responses here as a bit of a baseline for the rest of the presentation. Fantastic to see that we have an audience that's sort of getting going with this technology or is already using it really quite a lot in their organization. I hope that you will gain something from what I have to say today. And a few more questions that I'd love to ask you are what you think about end-to-end testing in your organization. Do you see it as something that's necessary for deployment safety at your company? Could you live without it? Yes, no. Another question I'd like to ask you is, do you think that it's very expensive to have these end-to-end tests running? Are they prohibitively expensive? And the last question I'd like to ask you is, what do you think about them as a bottleneck for your deployment machinery? Is that something that you experience in your company, or have you managed to find ways around it, depending on, of course, your stack and your flow and what kind of things you work with? One more note about me using this thing the whole time that I forgot to mention in the beginning. I've got a little bubble down here that's questions from audience. So we will be doing normal questions from audience at the end as well. But if you have questions that you think about while we're going on, you can throw it in the app too, and hopefully we'll get to them. Thank you so much for your responses here. Quite interesting, quite widespread, I'd say. I'm quite happy that we're at least all on the same page about it being fairly necessary to find this kind of deployment safety within our organizations. As we heard a little bit this morning as well, it's like such a powerful tool to catch these really big failures that you might not have caught with a unit or an integration test. But we seem to have a bit mixed answers across the board about how expensive or how much of a bottleneck they are. Moving on, so the big question when we were trying to deal with this is, for example, to start with, why do these end-to-end tests cost so much? And for us, then, running one end-to-end test is quite a, let's see if I can get used to doing this on the flow. Running one end-to-end test is quite a heavyweight operation. So this is us running one of our end-to-end tests. You start a full browser that occupies a full core at least, and several gigabytes of RAM for 30 to 60 seconds, or maybe a bit longer, maybe a bit less. But if we're comparing that to a unit test or an integration test, like, that's a lot of resources. On the other hand, if I wanted to run 100 of them, that would mean that I would need 100 cores available for me for a fairly long period of time. I'd need a hell of a lot of RAM, and if I were to put all of that on AWS instances and I were to leave these instances on, I would need 6 M5.4x large things, and they would cost me about $3,000 a month. That's quite a lot of money. This next command I will run is just to run several tests. So I'll see what happens when we run a lot of them in parallel. And I'm running them on a fairly new MacBook Pro that has 10 cores on it, which is quite nice. But we still see that as these browsers boot, they're making lots and lots of processors. They're taking up a lot of CPU time, and like, my overall CPU load here is spiking quite a lot. Let's see. They managed to run though, not too much of a problem. One thing that I will note is that these tests took longer than the one that I ran before, and one of these tests is the very same as the one that I ran before. And what I want to say there is that most people run their end-to-end tests in some kind of sequence, right? We will rent one or two of these machines, and we'll probably run a couple at the same time, which will let you, as a whole, run your end-to-end test suite on paper fairly efficiently. But what we found when we were running our end-to-end tests sequentially on these fairly beefy machines was that the theoretical time on paper was never the time that it actually took the suite to run. Almost always, you would have this kind of resource spillover where all of these browsers booting at the same time would make the other tests much slower. And that's sort of what I was trying to show you here. These tests were taking quite a bit of time. I think I might try and increase my font size here a bit. That might help. There we go. But another effect of this is that if we're running them all in sequence, it does scare developers off from making more end-to-end tests, because once you've got certain critical mass and your end-to-end test suite is taking 10 minutes, every developer knows that by adding another test, I'm going to take up more of everyone's deployment time. And for me, this is also like only the tip of the iceberg. Like, the problem of running 100 browsers at the same time, it's a compute problem, but I'm sure that we can solve it. Really, under the hood, running end-to-end test suites, you've got a big distributed system that you're actually testing. And there can be all sorts of network conditions in between that can fail. You might be testing third-party providers that can go down at any point in time. It's a fairly big problem. But we wanted to do something about this at least. So our aim was to build an environment that reduced the cost of running these end-to-end tests by a little bit at least. And our approach here was that we were like, well, we know that we need a lot of resources, but we also know that we only need them for a pretty short period of time. And we know that there's this thing called Lambda, or called Serverless, or whatever you'd like to call it, that is very good at rapidly scaling resources like this. So our idea was, can we start one serverless function per test in this Lambda? Before I move on to the solution, I'm going to ask you one more question about what you're using at the moment. Are you using any of these frameworks where you are working at the moment? Are you using Cypress, Playwright, something completely different, or nothing at all? And what I've done here as well is that I've segmented by a previous question. So what I was maybe looking for was to see that maybe some people who more extensively used end-to-end tests might be using one framework more than another. But what I'm seeing really is that we've got quite a wide spread. We don't have a dominance of like extreme end-to-end test users use this tool or anything like that. I also have some really bad news for you today, and that's that for those two people who are using Playwright, you're going to love this. But for everyone else, it might just be a little bit of fun rather than something that you can implement straight away. we use Playwright to implement this. We made the switch from Cypress about 6 months back. We didn't have a huge suite back then, so making that transfer wasn't too big of a deal for us. But like generally, our Playwright experience has been pretty top-notch. We definitely found that we had less flakes off the bat than we had in Cypress, but I'm sure that everyone's experiences there will be quite individual. So, what do you really need to run one end-to-end test? Well, you need the actual code of that test and all of the helper functions that you may have written in your end-to-end testing suite. You need all of the dependencies for that test to run. You might be using like a faking library that helps you to make nice-looking names so that you don't have to come up with themselves. And you need a browser, a full browser, normally quite heavyweight. When we were thinking about these components, as in this is what we need to run these tests on Lambda functions, we realized that the code for these tests, they're pretty small. That's only a couple kilobytes of data, and that's something that we can then load into the Lambda runtime just when we want to run the functions. And the real great thing about that is that we want to be able to iterate quickly on these tests. So I wanted to be able to write a test, run it straight away, see does it work, and I don't want to have to redeploy a Lambda every time. But on the other hand, the dependencies that you may need, they can be quite heavyweight, and also the browser itself is about 40 megabytes. So those were things that we chose to package into the Lambda deployment, and you install and upload that before you run your Lambda, and you don't need to change it quite as often. And scaling that Lambda then actually was a pretty simple thing to do. When you think about it in JavaScript terms, it's throwing away a bunch of API calls and then just doing promise.all on the responses. So for us, that seemed to be like a pretty easy part of it. And although some people are like, Lambdas, cold starts, that's something that I find difficult to deal with. In our context, like a 30 to 60 second long-running function, like a second's nothing for us. We don't really mind that much, to be perfectly honest. It's more the scaling that we're looking for here. And one more nice thing about this is that using 4 gigabytes of RAM on 100 lambdas for the full duration of a test suite for 60 seconds, that's about $0.2. So if I wanted to spend the same amount of money that I was spending on all of those VMs, I could run my test suite 15,000 times. That's quite cost effective. And probably I could halve the amount of RAM there as well if I was feeling a bit cheap, but I don't care that much. So Play Lambda, this thing that we've built in a nutshell, it provides a way for us to package these dependencies, nice way of just deploying that Lambda function for you. It schedules the tests that you have on many of these Lambda functions. And then a really, really important aspect of this is collecting the results in a meaningful way. A lot of end-to-end test development is looking at traces and figuring out what the hell actually happened in that browser, how do I fix it later on next time. One thing that I'd like to make note of, this is the library that we use to boot the Chrome function. It's called Chrome AWS Lambda. It's pretty tricky to do if you look in that source code. There are like 100 flags that it needs to pass to Chrome. So we love this library. It makes our lives much easier. But that also means that there's no other browser support here. We only run Chrome. Small demo, okay. Tell me about it. What's my next command? So these, I've written out the longhand forms here, but we just have a couple shorthands that make it a little bit easier. This pw::lambda is just a shorthand for the name of the library, which is Play Lambda, and I'm going to ask it for me, please, to run lots of tests. And there's no specific lots of tests. It's going to be exactly 100 tests. And if we cross our fingers very hard and we hope that the Wi-Fi in here is good enough, we will hopefully be able to see that running these 100 tests will take not the 15 minutes that it would if you were running them in sequence, but they should be coming back in soon. I think I'm getting a little bit slower responses here because of Wi-Fi. A little bit of a note about that run-up time is that what we do is that we run all of our, we have like a global setup function that runs before all of these end-to-end tests as well. That does things like making the users for the end-to-end tests, and that's something that can actually be reused between Lambda functions. So they're like kind of completely separated environments, but not entirely separated environments in some cases. And we're seeing a bunch of results coming in, and almost all of them are taking this shorter amount of time, right? They're not taking 20 to 30 seconds, they're taking more like 9 to 10 seconds, and just like that, they ran in 59 seconds blank. I'm pretty happy with that. Cool. We did it, and this is a screenshot, just in case that broke, of us actually running it in a minute in our deployment pipeline. This is cool, and I like this, but I want to throw it back to you one more time. This has helped us in some ways, but what problems do you think that this actually solved? Did it solve the problem of flaky tests for us? Do you think that it managed to help us solve the problem of slow tests? Do you think it managed to help us solve the problem of third parties affecting tests? Or maybe that it helped us with the cap, or the limit of end-to-end tests that we can make? Or do you think that it helped us solve the problem of having generally unreliable test environments? I'm loving to see these responses coming in because they are pretty much on point. For me, the easy yes, we managed to solve this are absolutely that we managed to solve the problem of slow running tests. We definitely have less resource spillover. We can definitely see them running much more consistently than they did before. And we definitely have better scalability of our end-to-end testing suite. It's certainly not a scary thing to do, to add another end-to-end test. It will never make the suite run for longer unless you're adding one very, 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 very slow test. But we generally have some good practice that makes sure that people don't do that. I'm going to spend almost all the rest of my time in this talk talking about flakiness, actually, because flakiness is a huge problem for us as a company, and I'm sure that it's a problem for some of you as well. And although that it hasn't solved flakiness for us outright, it's certainly made dealing with flakes easier for us. Flakiness, just so that we're all on the same page, they're tests that sometimes pass and they sometimes fail. If we all made end-to-end tests that passed 99% of the time, I think we'd be pretty happy, to be perfectly honest. But when you do the maths of running lots of these tests, the truth is that if you ran 199% passing tests, the suite as a whole would only pass 36% of the time, which suddenly doesn't look so good, doesn't look like such a great deployment experience. Most libraries for end-to-end testing have solutions to this sort of built in. They automatically retry your tests for you so that it has to fail 3 times in a row before you consider it an actual failure. But it's a very difficult problem to deal with. The numbers are against us. And what makes them really hard to deal with is that they are very, very difficult to figure out how they're flaking up front. It's very difficult to run a test many, many times and look at all the failure responses. Chasing them, therefore, is normally quite time-consuming. I need to budget time context switch time, a couple hours a week, where I go and look through traces that have been collected throughout the course of the week and see if I can make any kind of correlations between these ones. Normally, there are environment differences between your local and your production environment or your staging environment as well, and that kind of thing can make a really big difference on the flake rate. And just generally, these big distributed systems are very complicated, and one service failing kind of in one place at one point in time can make whole tests fail and can be very difficult to deal with. So normally when I see teams trying to deal with this problem, they really have to try and stay on top of it. Don't let them get out of hand. And they might do that by running their end-to-end test suite every 20 minutes in the background and collecting all of these traces. But almost always they have to, budget time for looking at them almost every week. But I thought to myself, is that the way that it has to be? I think to myself as a DevOps engineer, I'm always trying to say can we do more of the work up front? Can we shift it further left? And for me, I was asking myself, if we knew the flake rate of an end-to-end test before it was in master, then we would know, we would be able to see the flakes, fix a lot of them, and then make sure that we reach a pretty good baseline before we put it straight into the critical path of people's deployment machinery. And Play Lambda is a thing that helps us do that as well. So this next command runs very similar to previously. It runs Play Lambda, it runs test, and it runs one test, but I'm asking Play Lambda now to run this one test for me 100 times, please. And the idea then is that I can write my test locally, I can run it 100 times, and immediately, a minute later, I'll be able to see, failed in about 30% of the cases, and here was the most common reason. I'll sort of let that run in the background for a little bit. I've prepared a couple of flakes that we kind of see. So this is the kind of report that you get back from Playwright. It's a fairly complicated test that I think votes on a kind of Mentimeter question. And here, for example, looking at, it's quite small text, isn't it? That's a little bit bigger. Here, it's looking for a drop-down, because I think that this test is trying to make sure that you can reset results from this dashboard, but it can't find this drop-down. And I'm pretty sure that that's because this end-to-end test user is making lots and lots of presentations, and the presentation it's looking for isn't in this list because there are so many. So if I knew that when I was developing the test, I could search for the test in this search interface and make sure that that was almost never a problem. Maybe even make a helper function so it doesn't affect my colleagues so much. Cool, this worked as well. 57 seconds, 100% success rate. I know that I can merge it to master. So there are a few gotchas here. There's differences in environment will still make a big deal here. Hopefully, and we at Mentimeter are investing a lot of resources in making reproducible staging environment so that you can very easily run your local code against an environment that will be more similar to where it's actually going to run eventually. But at the end of the day, even fixing most of the flakes up front isn't going to solve it for you. Tests will still break later on, and you will still need to budget some amount of time to fixing those flakes as they occur randomly, sort of thing, in the future. But where does this really leave us at the end of the day? Well, it's given us a couple things at least. It's told us that speed and resource consumption of my end-to-end test suite at least isn't as much of a problem. And the other thing I've tried to show you today is that using this kind of tooling, hopefully you'll have more powerful tools in your arsenal as a developer to combat flakes up front and make it less of a problem where you can hit it well. And in my head, end-to-end test suites are still super powerful, but maybe slightly less expensive. So I ask you, dear audience, oh Pharaoh, what should our testing pyramid be? Does this change the look of the testing pyramid that you're using in your organization? Could we have maybe a slightly wider pyramid, or a pyramid that doesn't use any integration tests, or a very heavy integration test kind of pyramid thing? And my last question that I'm going to ask you today is, do you think that this notion of a testing pyramid is a little bit outdated? Could we be chatting about this in a different way? Are our testing tools leveling up, and should we maybe rethink this? And I wasn't expecting so much yes, if I'm going to be completely honest, but I think it's fantastic that we've got this as maybe a conversation starter. Feel free to chat with each other in the break about what a testing pyramid in your organization means to you, and whether or not that's something that you're actually adhering to. Make it an active choice, not a passive one. So finally, from me, I have some good news, and that's that we open sourced this library a couple of weeks ago. So if you are one of those 2 people who use Playwright in your organization already, and please go home and give it a go. Massive disclaimer that we're not really following the Playwright release cadence at the moment, so it's a little bit best effort, but feel free to have a go, have a dive, and see what happens for you. And that is all for me. Thank you very much. So I have 8 questions in here. Shall I start with them?
8?
Yes.
Yeah, shoot.
Yes.
Shoot.
But let's agree that you take 5 and then I will say whether you can proceed or not.
Absolutely. Good idea. So this looks like the most upvoted question. Are you running your end-to-end tests against a real environment or just against a build? Because parallel tests on an environment might affect others. So during deployment, we run everything against stage, which is a environment that is always what's in between merge and production. And running things parallelly there works quite well just because Heroku handles rolling deploys there pretty decently. And as long as you kick off your end-to-end tests after your component was meant to have been deployed, you can have like a safe enough guarantee there. Generally, like I said, we're trying to build lightweight environments that are very like stage so that people can do this locally as well. I will mark that as answered. Do you have a mechanism to rerun the tests that failed in that batch? Playwright does that for us. So you just tell Playwright, try it up to 3 times before you consider it a real failure. And we're running the actual Playwright CLI inside of the Lambda. So as long as we use the same config, then Playwright will rerun that 3 times. That is the way we do retries. Do you clean your test environment often? Seems like those tests might generate a lot of trashy data in the database. Right, so we have lots of... What I like about our test suite is that there's a lot of functionality that's shared. We work a lot with page object model structure kind of thing. So you can share the way the pages are meant to look between developers. But then we also have a bunch of helper functions in there for things like making users, upgrading those users. And normally when we make those setup functions, we ask people very nicely to make the equivalent teardown functions. So normally cleaning up the test database is part of running the test. Other than that, it's just stage, and there is some trash in there. We don't mind too much. Comment, not a question. Difficult to answer polls without knowing what it's meant by end-to-end. It's all across your systems with this specific product team domain, or is it a subset of domains? If I'm interpreting the question correctly, it's like, do you run it all over the place with your whole system, or do you run it just in certain places? And for us, we only have one end-to-end test suite, and that runs against the entire system. But if I've misinterpreted that, then put your hand up in a bit and we can chat about it, or come to me afterwards. Definition of end-to-end, end-to-end testing. Tests that use preferably like the actual user interface. So we click on all of the buttons in our system. We don't know anything about the API, and we only look at the real user-based inputs and outputs. I guess you could think of it as a bit like black box, which was one of the keynote speakers mentioned in their thing yesterday morning. And I think I'm about 5 questions in, but how am I doing for time? I'll push a little bit more then. Is your tech stack all services, i.e. no containers or hosted boxes? No, it's not. We deploy to Heroku. We have like super normal Ruby on Rails backend and a couple of front ends that run Next.js. They run on containers or VMs, depending on what Heroku's done for us. It's also pretty simple. We feel it's a little bit serverless. We only have to like pull a slider kind of thing to scale, but it's certainly not a fully serverless setup. How is the SUT provided for tests? Does a single test boot up an instance of the system under test? Like I mentioned, we're using our stage environment. How do you connect CI job to Lambda's infra cluster? Is Jenkins running there? We run Concourse that runs our tests against our staging environment. We're trying to make environments where we can run them in pull requests, but we can't do that at the moment. So definitely only in the merge to master flow. What was the effort to switch from Cypress to Playwright? At the time, we didn't have that many Cypress functions, and that's a bit of a learning lesson from us. We only had 5 Cypress functions, and they were still taking 6 minutes of every deployment. So we weren't making more Cypress functions because we were like, they're already so flaky, they're already taking so much time, we don't really want to make more tests. When I wrote the call for proposals for this talk, we didn't have 100 end-to-end tests. We probably had, I want to say, 40, 45, and in the last 3 months, we've gone from 45 to 115 end-to-end tests. So I think the tooling here has helped a little bit in people's ability to make more tests. How often do you change the package browser? With the release cadence of Chrome AWS Lambda, which is pretty bad, so we don't have that recent a Chromium version, which definitely is like a pitfall with relying on like this kind of solution. Shall I leave it there?
Let's take the last one.
The last one. No, that was all. That was perfect. Fantastic. I've answered all of the questions.
Thank you, Oliver. What came to my mind is that one KPI, answered questions per minute. So you are the clear winner of this year and all the history of Nordic testing days. And the second is that I know that the Fika is really important for Swedish people.
Yeah.
So I understand that when you run your test serverless way, your company will get some benefit because your AWS bills are not so high anymore.
Something like that, sure.
Yeah, and also, as you don't have time for coffee breaks, the coffee bills are also reduced.
Exactly.
Yes, but now the question is that how you stay motivated without Fika breaks?
Oh, that's a fantastic question. I become motivated by the smiling faces of my developers when they manage to deploy things in lightning time.
Thank you.
Perfect. Thanks very much, man. Woo.